Hello, my name is Ashley Wilkes and I'm presenting Module 10 Lab. The heart is a hollow cone-shaped muscular pump. The heart size varies from person to person, but the average adult heart is 14 centimeters long and 9 centimeters wide. The heart is boarded laterally to the lungs, posteriorly to the vertebrae column, and anteriorly to the sternum. The base of the heart is positioned beneath the second rib. The heart is the inferior end extends down towards the left. The pericardium is a double-layered sac that encloses the heart and proximal end of the blood vessels. The fibroneous pericardium, composed of connective tissue, surrounds more delicate serous layers. The innermost layer of the vascular pericardium covers the heart. At the base of the heart, the vascular pericardium turns back upon itself and becomes the parotid pericardium layer. The pericardium is a space called the pericardial cavity, which contains a small volume of serous liquid. The walls of the heart are composed of three distinct layers: epidem, myocardium, and endocardium. Endocardium corresponds to the vesicular pericardium and protects the heart by reducing friction. It's a connective tissue and it's covered by the epithelium. The deeper portions often contain adipose tissue. The thick middle layer of the wall of the heart is the myocardium, which consists layerly of cardiac muscle and pumps blood out of the heart chambers. The muscle fibers in the plane are separated by connective tissue richly supplied with blood and lymphatic capillaries. The inner layer of the heart, while endocranium, consists of epithelium and underlying connective tissue. It also contains blood vessels and specialized cardiac muscle fibers called Purkinje fibers. The endocardium is continuous with the lining of the blood vessels attached to the heart. The heart is initially divided into four chambers, two on the left and two on the right. The upper chambers are called arteria within the walls and receive blood from the arteria and force blood to the walls of the artery. A solid wall like a septum separates the arterium and the vesicles. As a result, the blood never mixes from side to side. The arterioventricular valve on the right side and left side ensure one-way blood flow between the atria and the vesicles. The right atrium receives blood from two large veins, that's superior inferior vena cava. The large transcripular valve, which has three tapered projects called cusps, lie between the right vesicle and prevent backflow. Strong fiber strings called choroids tendides attend to the cusps and the tricuspid valve and vascular sides. These strings originate from small mounds of capillary muscle tissue, cardiac muscle tissue called papillary muscle. The muscle contracts and the valves close and pulls on the choroid tendides to prevent the cast from swinging back. The right vesicle has a thinner muscular wall on the left than the left. This is because the right does not need to pump as far in heart as the left does. When muscular walls on the right ventricle contract, blood inside under increasing pressure in the tricuspid valve closes. As a result, the only exit for the blood is the pulmonary trunk, which divides into form the right and left pulmonary arteries. At the base of this trunk is a pulmonary valve, which consists of three cusps. The valve prevents backflow in the left. Blood low in oxygen and high in carbon dioxide enters the right atrium through the vena canal and coronary sinus. As the right atrium wall contracts, the blood passes through the tricuspid valve and enters the chamber on the right vesicle. When the right vesicle contracts, the tricuspid valves close and the blood passes in the pulmonary trunk and its branches. From the pulmonary arteries, blood enters the capillaries associated with the alveoli of the lungs. Gas exchange occurs in the blood in the capillaries and the air in the alveoli. The oxygen-rich blood, now relatively low in carbon, returns to the heart through the pulmonary veins and leads to the atrial. The left atrial wall contracts and the blood moves through the mitral valve and into the chamber of the left ventricle. When the left ventricle wall contracts, the mitral valve closes and the blood passes through the atrial valve and into the aorta and its branches. The heart functions in three main ways: by pumping blood, by creating body circulation, and transporting necessary nutrients in blood. It also is important because it also transfers out the waste, which would be carbon dioxide. I chose a football, squishy like pillow football, because it's cone shaped like a heart, and I can simulate the pumping that the beats that a heart would produce. I'm squeezing it to show how the blood circulates through the body, because the pumps are what's making the blood circulate. The information in this chapter is very important to me moving forward in preparing for my career, because I'm going into the medical field, and it's very important to understand how the body works and how the blood and vital functions are performed, and what is normal versus what is abnormal.